Okay, we are going to continue our discussion of the new Keynesian model today. We are going to finish talking about all of the different components of the model and put it together and see how it determines the output gap and inflation and equilibrium. And then my hope today is actually to go through at least 2 or 3 kind of full practice problems together, so that you guys can see how to actually apply the model in a situation that you might see like on a lab assignment or an exam. So let's just really kind of quickly review what we did in the last class. So the new Keynesian model is this model of the transmission mechanism, which explains how changes in the central bank's policy setting, which is the short-term nominal interest rate, affect the broader variables in the economy that the central bank cares about. The 2 most important ones that we're discussing are the output gap, as well as the economy's rate of inflation. The new Keynesian model basically has 2 key sides, a supply side and a demand side. In the last class, we talked at length about the supply side of the model and how it is characterized by this thing called the new Keynesian Phillips curve. All right. Hopefully you guys remember what that new Keynesian Phillips curve looks like. It says that inflation is equal to expected inflation plus some parameter times the output gap plus a supply shock. Okay. That simple equation, that simple Phillips curve, was basically derived from an underlying microeconomic story about monopolistically competitive firms, some of whom have sticky prices, the others who have flexible prices. Okay? The demand side of the new Keynesian model is going to be characterized by something called an ISMP equation, which you might imagine combines both an IS equation or IS curve, similar to like what you might have seen in your intermediate macro class, and a specific rule for monetary policy, a monetary policy rule, which we'll talk about in a minute. That rule is going to look a lot like the Taylor rule that we talked about in the last section of the course. Really quickly, to review the IS equation. Remember, the IS curve shows this downward sloping relationship between the real interest rate and the level of output in the economy, okay? It slopes down for 3 reasons that we discussed. One, lower real interest rates should increase consumption because it discourages savings. That's called intertemporal substitution. The other is that a lower real interest rate will encourage investment because it lowers the opportunity cost of investment, or in some cases, it lowers the direct cost of borrowing for investment purposes. And a lower real interest rate should also increase our country's net exports, right? Because it makes the value of the dollar relative to other currencies go down. As foreign interest rates are now higher than domestic interest rates, the demand for foreign currency will go up relative to the demand for domestic currency. Okay, the IS equation relates basically the output gap to changes or deviations of the real interest rate from this equilibrium real interest rate, R star, plus a demand shock, okay? And we saw that there were 3 key points here. When output is equal to potential output, then, and there are no demand shocks, so U is 0, the real interest rate, that is the nominal rate minus inflation, should be equal to the equilibrium real interest rate. So the IS equation is theoretically consistent in that way, right? Real interest rates will equal R star when output is equal to potential. All right, that is the stance of monetary policy is neutral. Anytime, so this is going to be important for today's discussion, anytime the real interest rate, I minus pi, is below the equilibrium real interest rate, so that the stance of monetary policy is loose or accommodative, then what happens to output? It's going to start to increase above potential output. So accommodative monetary policy stimulates output above potential, right? This real interest rate term enters the IS equation with a negative sign, okay? And then, of course, if the real interest rate rises above R star, it does the exact opposite, right? That is a tight or unaccommodative monetary policy, which causes output to fall below potential, okay? And then the last thing is that there are some factors in the economy that you can't account for that affect output, not directly related to the interest rate. And so we just kind of group all of those terms together as this demand shock. Fiscal policy, asset price changes, other types of changes in consumer sentiment, et cetera. Okay. Now, the third and final element of the new Keynesian model that helps us characterize the demand side is going to be an explicit monetary policy rule, okay? Now, instead of assuming, so in your intermediate macro class, you might, when you talked about the ISMP model, or even the ISLM model, you might have just assumed that the interest rate was set completely by a central bank and it was fixed, okay? We're going to expand on that here and assume that the interest rate actually follows a specific policy rule, and it's going to be a version of or a generalized version of the Taylor rule that we saw earlier, okay? This is going to be what that interest rate rule looks like. And in fact, I'm going to actually simplify this in a minute. So the central bank's interest rate setting is going to be equal to R star, the equilibrium real rate, plus target inflation, plus some coefficient beta pi times the inflation gap, plus some coefficient beta y times the output gap. This is very similar to the Taylor rule, right? What are the differences? Beta pi and beta y in the Taylor rule were set equal to 1/2, right? So this way of writing it generalizes that rule to allow for different size coefficients on the inflation and output gap. To make the arithmetic as easy as possible, what I'm going to do is I'm going to assume that beta y is actually 0. So the central bank in our model is really only directly responding to changes in inflation from target. Now, you don't be concerned about this. You can set beta y equal to some positive number. It's not going to change the qualitative characteristics of our model in any way. It complicates the analysis, but none of the basic results differ. So to make this as easy and as straightforward as possible, I'm just going to set beta y equal to 0, okay? Now, the other difference you might see here is that instead of actual inflation, like the Taylor rule had, we've got target inflation here, all right? So let me just really quickly, on a separate sheet of paper, show you guys how this version of the interest rate rule is related to the Taylor rule. Okay, so let me zoom out here a little bit. Okay. You guys recall that the Taylor rule has the federal funds rate target equal to the equilibrium real interest rate plus actual inflation plus 1/2 times the output gap, that's y tilde, plus 1/2 times the inflation gap. Now, if we just if we interpret the interest rate in our problem as the funds rate, then we can just replace I, F star with the interest rate I in our model, okay? Now, let me do a little trick here. I'm going to add and subtract target inflation to this equation. So plus pi t minus pi t. That's basically like adding 0 to the equation. Now, when I do that, we can rewrite this as R star plus target inflation. Now, you'll notice there's now 2 inflation gap terms, pi minus pi t here and a pi minus pi t here. That's essentially 1.5 times pi minus target inflation. And if I assume that the coefficient on the output gap, let's say, goes to 0, then this is essentially what the Taylor rule looks like, okay? So the equation in the slides treats beta pi as this 1.5 number, okay? So the modified Taylor rule that I'm going to use in the actual model is fully consistent with this kind of Taylor rule here, except I'm essentially just getting rid of the output gap argument, okay? So I don't want you to think that because they look different, they're really any different. They're kind of one and the same thing here. Okay, 3 quick points I want to make about the Taylor rule that are going to be important. You'll notice that when the central bank adjusts, or I'm sorry, you notice that the central bank is going to adjust its policy rate up anytime actual inflation exceeds target inflation, right? So what this Taylor rule shows us then is that policy is tightened, becomes more restrictive if inflation goes above target. If inflation falls below the target, the interest rate is going to fall. Both of those things are going to be true as long as beta pi is a positive number. That 1.5 term that I just got on this separate piece of paper satisfies this condition. So the simplified or modified Taylor rule that we're going to use shows how the central bank tightens or loosens monetary policy in response to deviations of inflation away from target inflation. Okay.
So the central bank.
Sorry, go ahead.
The central bank tightens policy when there's a bigger...
Okay, so Lauren, the central bank here is going to tighten policy in the sense that it's going to raise the nominal interest rate, the variable on the left-hand side, anytime inflation pi is bigger than target inflation, right? So if inflation is bigger than target inflation, that means the inflation gap is positive. The interest rate setting is going to be beta pi times that inflation gap number. So the interest rate is, the central bank will raise the interest rate in response to higher than target inflation. It will lower the interest rate in response to a negative inflation gap. That's going to be true if the coefficient beta pi is greater than 0, which it will be in our exercises.
Perfect, thank you.
Now, the size of beta pi, if you think about this, is going to measure kind of the strength with which the central bank responds to changes in the inflation gap. If beta pi is a really big number, let's say 100, then even a small increase in inflation above target inflation is going to cause the central bank to want to ramp up the nominal interest rate a lot, right? So policy is going to be very restrictive in that case. If the inflation rate falls a little bit below target, a really big number for beta pi means that the Fed will accommodate very quickly and strongly. Lastly, I want to point out is that the Taylor rule is also theoretically consistent. Imagine for a moment here that inflation is exactly equal to target. Well, if that's the case, then according to the rule, I is equal to R star plus target inflation. And since target inflation is equal to actual inflation, then that means I is equal to R star plus pi, which means that I minus pi, the real interest rate, is equal to the equilibrium real interest rate. So just like the IS equation is theoretically consistent, when the real rate is equal to R star, output is equal to potential. When the real rate is equal to R star in the policy rule, inflation is equal to target inflation. So all of those nice long-run equilibrium conditions are satisfied here. Okay, any other questions about that before we move on? All right, how do we then derive the full ISMP equation? It's pretty straightforward, okay? What we want to do is to characterize the demand side of this model. We want to derive a single equation that relates the output gap to inflation. The new Keynesian Phillips curve, which is the supply side of the model, was this upward sloping line in output gap inflation space. We need another condition, a downward sloping ISMP curve in output gap inflation space. So we want to put the IS equation together with the monetary policy rule. That requires just a little bit of algebra that I'm 100% confident you guys can do, okay? So again, here is our IS equation. The output gap is equal to the negative of this interest rate gap, right? The real rate minus R star plus a demand shock. And here's our modified Taylor rule, okay? Now, you guys will notice here that in the IS equation, we have an I minus an R star term, right? Well, from the monetary policy rule, we can solve for I minus R star in terms of target inflation and the inflation gap, okay? And if we do that and then plug the result into the IS equation, what do we get? We get that the output gap is equal to the negative of what? I minus R star, that is equal to, from the monetary policy rule, target inflation plus beta pi times the inflation gap. And then we can't forget about our minus pi in the IS equation. And then we also can't forget about our demand shock, U. Now, really all we need to do is solve this equation for pi in terms of the output gap. Remember, we want inflation to be the left-hand side variable here because that's the variable we're graphing on the vertical axis, okay? Well, notice that inside these squiggly brackets here, I have essentially a beta pi times the inflation gap term minus another inflation gap term. So that becomes negative beta pi minus 1 times the inflation gap plus the demand shock, okay? Now let me swing the inflation gap term to the left-hand side and the output gap term to the right-hand side. And then I'm going to divide both sides by beta pi minus 1 and then add target inflation to both sides of the equation. That way I can solve for inflation in terms of the output gap as well as the other exogenous variables in my model, which is target inflation and the demand shock. This is the ISMP schedule or ISMP curve. And fully characterizes the demand side of the new Keynesian model. Again, let me restate this. Why am I doing all this clumsy algebra? It's because I want to derive a relationship between inflation and the output gap that I can join with Phillips curve so that I can determine the output gap and inflation in equilibrium, right? Okay, any questions about that so far? Good, let's go and look at a picture, okay? Again, I'm not gonna ask you to work through multiple lines of algebra on your exam, okay? I'm not likely to do that. What I want you to do is be able to apply the new Keynesian model mostly in a graphical setting, okay? So at the top of the slide here, I've just restated the ISMP curve that I derived on the last slide, okay? Here's what that ISMP schedule or curve looks like, okay? We again graph inflation on the vertical axis with the output gap along the horizontal axis. Now, what does this particular line show us? It shows us all of the combinations of the output gap and inflation that satisfies the ISMP schedule for given values of target inflation and the demand shock, which is why, be careful here, when I label my ISMP curve, I put this parenthetical argument in there that says It assumes that we know what the value of target inflation is, and we know that the value of what the demand shock is. Okay, so as an example, let's suppose that the output gap is, what if I tell you that the output gap is 0 and there are no demand shocks that are happening? And I also tell you that the target rate of inflation that the Fed has is pi 1, okay? Then we can look at the ISMP curve and see that actual inflation should be equal to target inflation, pi 1, minus this 1 over beta pi minus 1 term times the output gap, which is 0, minus the demand shock, which is 0. So for a 0 output gap, inflation is equal to pi 1. The rest of this line shows all the different output gap inflation combinations that satisfy the ISMP curve given target inflation of pi 1 and no demand shocks. What do you think happens to the ISMP curve if target inflation changes or if there is a demand shock that occurs? It causes the whole ISMP schedule to shift, just like supply shocks and changes in inflation expectations cause the Phillips curve to shift. Okay? All right, now let me talk for a minute about this idea here that the ISMP curve is a downward sloping curve. Do you guys see anything in this model that must be satisfied in order for the ISMP schedule to be downward sloping? Have I made an assumption about any of the parameters in particular, given the way I've drawn it? What is the slope of the ISMP curve? It's given by this term -1 over beta pi minus 1, correct? I'm saying that that's a negative number, so that the ISMP curve slopes down. Well, if I'm saying it's a negative number, what does that imply about beta pi? It's got to be bigger than 1, okay? This is a major point in the new Keynesian model, okay? We are going to assume that beta pi is bigger than 1. The 1.5 term that's consistent with the Taylor rule that I showed you guys earlier satisfies this. What happens, Michael, if beta pi ends up being less than 1? Exactly. Then you get a -1 over a negative number and the ISMP curve slopes up, okay? So a negative ISMP curve requires that beta pi be bigger than 1, meaning that the central bank is responding to inflation gaps sufficiently strong, right? In particular, it's raising the nominal interest rate more than 1 for 1 in response to an increase in inflation. If it doesn't do that, if it's less than 1, then the ISMP curve is going to have an upward slope to it, okay? Now let's think about this a little bit more, okay? Hopefully this tells you why the ISMP curve is negatively sloped. Michael, as inflation rises, what does the central bank do in this model to the nominal interest rate? It's going to increase the interest rate, right? Higher inflation causes the central bank to raise the nominal rate. But Michael, specifically, how much is it going to raise the nominal rate by? Beta pi times the increase in inflation. If beta pi is bigger than 1, then what are we saying? That the nominal rate goes up by more than inflation. Okay, now if the nominal rate goes up by more than inflation, Michael or anybody, what happens to the real interest rate? If the nominal rate rises by more than the rate of inflation, what happens to the real interest rate? The real interest rate is I minus pi. So if the nominal rate goes up by 2% and inflation goes up by 1%, what's happening to the real interest rate? Does it go up or down? It's got to go up. If the nominal interest rate rises more than the increase in inflation, the real interest rate goes up, right? Now, what happens to the output gap if the real interest rate goes up in the IS equation? It's negatively related to the real interest rate. So a higher real interest rate lowers the output gap. That's why the IS&P curve has a negative slope. Higher inflation leads to higher nominal interest rates. And because beta pi is bigger than 1, it leads to higher real interest rates, which should lower the output gap in the IS equation. We're going to work through, this is a critical part of the transmission mechanism that we've got to work through today. Yeah. In most applications, I'm going to ask you to do a graphical analysis, and all you'll need to know is that it's greater than 1. Beta pi bigger than 1 is what's known as the Taylor principle, okay? And so the basic new Keynesian model will satisfy that Taylor principle. We'll spend some time in the next class, hopefully, talking about what happens when the Taylor principle is violated. Okay, let me ask you another question related to this. What happens if the central bank gets extremely aggressive in combating inflation? In other words, beta pi is a large number. What happens to the IS&P schedule if beta pi goes from, let's say, 1.5 to 1.5 million? Levi? If beta pi gets to a really large number, then this slope term basically goes to 0, right? And so the IS&P curve is going to start to get flatter, right? And so in that sense, then, it takes, or a given increase in inflation is going to raise the nominal interest rate by a lot, which raises the real interest rate by a lot, which causes the output gap to go down by a lot, okay? So the more the central bank aggressively tries to stabilize the inflation gap, the flatter the IS&P schedule becomes. If beta pi, Levi, goes all the way to infinity, the slope goes to 0, and the IS&P schedule becomes perfectly horizontal, okay? If beta pi goes to 1, what happens to the IS&P curve? The slope is infinite, right? And the IS&P curve becomes vertical. Anything lower than 1, and the IS&P curve becomes upward sloping. Okay, just really quickly before we do some applications here, there are 2 possible ways in which the IS&P curve can shift, okay? You can take a look at the equation and see that it's any time there's a change in target inflation or a change in the demand shock, okay? Let me ask you guys first, what do you imagine happens to the IS&P curve if there's, let's say, a positive demand shock? So the government implements a fiscal policy which raises government spending and output goes above production, and so there's this positive demand shock in the economy. What is going to happen to our IS&P schedule in that case?
The curve's going to shift outwards.
Sorry, Lauren, say it again.
The curve is going to shift outwards.
Yeah, the IS&P curve is going to shift out, and it's going to shift out by the size of the demand shock. Very good, okay? And you can see that directly from the equation, right? Imagine for a moment that inflation is equal to pi 1, which is also target inflation, okay? Then pi minus pi t is equal to 0, and in that case, then, the output gap is simply going to be equal to the size of the demand shock. So the IS&P curve here would shift up, or maybe more logically shift to the right by the size of the demand shock here. Now notice how particular I'm drawing this. Here's the new IS&P equation where target inflation is still equal to pi 1. That hasn't changed, but the demand shock is now positive. A negative demand shock, a contractionary fiscal policy, would do the exact opposite, shift the IS&P schedule to the left by the size of the shock. What about let's say there's a decrease in the inflation target? What if the Fed announces a reduction in its target rate of inflation from, let's say, pi 1 to pi 2? 2% to, let's say, 1.5%. what happens to the position of the ISMP schedule in that case? It's going to shift to the left or down, right? So for instance, for a given, for an output gap of 0, and let's say no demand shocks, if target inflation falls from pi 1 to pi 2, then actual inflation would fall from pi 1 to pi 2. Or if you want to read the graph horizontally, perhaps the easier thing to do would be to say, okay, what if inflation stays at pi 1? Then inflation minus target inflation is equal to pi 1 minus the new lower level of inflation, pi 2, in which case the output gap would be equal to beta pi minus 1 times that change in inflation, which you can calculate from the ISMP curve. So the ISMP curve in this case shifts to the left by this amount. This number is less than 0 because pi 2 is less than pi 1. Okay, so changes in inflation expectations and supply shocks cause the new Keynesian Phillips curve to shift around. Changes in the demand shock and target inflation cause the ISMP curve to shift around. Anytime one of those events happens in our economy, that's going to cause a disturbance in the equilibrium business cycle. Okay, do you guys have any questions then about so this kind of fully characterizes the demand side of the model. When you're graphing these on your own, be very careful about labeling the axes and then labeling this correctly. So it's the ISMP curve, but it's for given values of target inflation and the demand shock. If any of those change, you need to be able to show me that on the graph. Okay. Let's work through some examples then together. Let's start with a negative demand shock. Okay, so first of all, here's likely what I would show you on an exam or in a lab setting, okay? I will likely go ahead and write the equations of the models for you, okay? So you don't have to, if you do this more than a few times, you will probably memorize what these equations look like. But here are the three key ingredients of the new Keynesian model: our Phillips curve, our IS equation, and our monetary policy rule, okay? Now, to analyze the model graphically, what did we do? We took the IS and the MP curves and we slammed them together to generate the IS-MP schedule, and we derived that several minutes ago, okay? The Phillips curve and the IS-MP schedule jointly determine, here's the key thing, they jointly determine the equilibrium values of the output gap and inflation in the short run, that is, over the business cycle. That's what the new Keynesian model is useful for. It's trying to understand how the monetary policy rule, and that is changes in the policy setting, are going to be transmitted through the rest of the economy and determine in equilibrium what the level of the output gap and inflation is going to be. What the central bank does, or what policymakers do then, is they consider a bunch of different policies and see how that affects the output gap and inflation. And then they can evaluate those different policies using something like a loss function. But to do that, you need an actual model of the economy, a model of the transmission mechanism. That is how interest rates get transmitted to inflation and the output gap. Where does the equilibrium occur in the new Keynesian model? Well, obviously at the intersection, right, of the Phillips curve and the ISMP curve. At that intersection point, the combination of the output gap and inflation satisfies both equations simultaneously. There's basically two equations, the Phillips curve and the ISMP curve, and two endogenous variables, the output gap and inflation, okay? I've drawn the Phillips curve for a level of expected inflation equal to pi 1 and no supply shocks, and the ISMP curve for a level of target inflation equal to pi 1 and no demand shocks. And so the equilibrium point here is a zero output gap. That is, output is equal to potential output, and inflation is equal to target inflation, which is also equal to expected inflation, pi 1. So that's the initial point of this model, all right? Now, here's what I want you guys to work through with me. What happens if there is a negative demand shock in the economy? Let's suppose there is a pandemic-related recession that causes people to drop their spending below normal level, okay? And how is that going to affect the equilibrium values of the output gap and inflation in this model? I want you guys to answer that question graphically by showing what curves shift and what happens to the equilibrium point. But then really more importantly, I want to spend some time going through the logic of the transmission mechanism. And that is how the equilibrium comes about. Okay, so let's take this one step at a time. If there's a negative demand shock, what is going to happen graphically to the new Keynesian model? Does it affect the Phillips curve or the ISMP curve?
ISMP.
Affects the ISMP curve. And what direction does the ISMP curve shift? Going to shift in or to the left. Perfect, okay? So the ISMP curve is going to shift to the left by an amount that's equal to the size of the negative demand shock, okay? So you guys can look at the graph there and see what's going to happen in equilibrium. We're going to move from this point here, the initial intersection, to the new intersection point, all right? Now, you will notice that the new equilibrium point has a lower output gap and a lower level of inflation. So what the model predicts is that a negative demand shock is going to send us into a recession. The output gap is going to fall and inflation is going to fall below target. However, you will notice that the output gap in equilibrium does not fall by the full amount of the shock, nor does inflation fall by the full size of the shift. In other words, what's going on in this model is that the output gap and inflation seem to be partially stabilized in response to the actual shock. Inflation and the output gap are not falling by the full size of the shock. Something is baked into the model that is allowing the output gap and inflation to be at least somewhat stabilized in the face of this bad negative demand shock, okay? And that's what I want you guys to master here, is to understand the transmission mechanism in the model. So let's go through these steps together, okay? Why is it that the output gap does not fall by the full amount of the demand shock? Why do you think? What does your intuition tell you? Levi? Sorry? Not directly, no. It's the fact that there is a systematic monetary policy rule baked in or embedded into the model. So Levi, what's going to happen here is when output falls and inflation starts to fall, the central bank is going to respond to that. And they're going to respond to that by doing what? Lowering interest rates. That effort to lower interest rates does what? It helps stimulate the economy to offset some of the original demand shock. Now let's go through the equations one by one so we can see precisely how this happens, okay? First off, there is a negative demand shock, okay? Now I want you guys to pin your eyeballs here on the equations. I want to really discipline the way you're thinking about these problems and you're viewing the business cycle. And we do that by viewing the world through the lens of a model, okay? If the demand shock occurs, right, then what happens to the output gap in the IS equation? It immediately falls by the size of the demand shock. Let's say a 1% drop in U causes the output gap to fall by 1%. That's the first step here. So U goes down, the output gap goes down. Now, If the output gap falls by, let's say, 1%, what happens to the rate of inflation in the Phillips curve? If the output gap goes down by 1%, then inflation, all else equal, is going to go down by kappa percent. That is kappa times the demand shock. Okay? So you see how a shock to the demand side of the economy will get fed through to the supply side of the economy because inflation depends on the output gap. Okay? Now, if inflation falls, stay with me here, if inflation falls by kappa times U, then how is the Fed going to respond to that development? Look at the monetary policy rule. If inflation's going down, what's going to happen to the nominal interest rate? It's going to go down by beta pi times the change in inflation, which was kappa U. So the nominal interest rate falls by beta pi times kappa times U. Everybody got that? Okay. Now, how does that change in the policy setting feed back into the IS equation? Because the interest rate is in the IS curve. Well, to answer that, we need to know how this policy doesn't affect the nominal interest rate per se, but Michael, this was getting back to what I was grilling you about earlier. How does it affect the real interest rate, I minus pi, okay? How is the real interest rate affected here? If inflation falls and the nominal interest rate falls by beta pi times the change in inflation, what happens to the real interest rate? That is I minus pi. If pi goes down and the interest rate goes down, the nominal rate goes down, we don't know the direction that the real interest rate moves unless we know that I changes by more than pi, right? Because it's I minus pi is the real interest rate. But what do we know about that? The change in the real interest rate would be beta pi times kappa U minus kappa times U. That is beta pi minus 1 times kappa times U. We know that's got to be a number bigger than 0. Why? Because beta pi is bigger than 1. Okay? So because the Fed here responds aggressively to the inflation gap, then we know that the real interest rate is actually going to fall, not just the nominal interest rate. Okay? Now, if the real interest rate falls, what happens to the output gap? It enters the IS equation with a negative sign. Stay with me here. I know this can get tiring towards the end. We're almost there, okay? If the real interest rate is going down, then the output gap goes up, right? The output gap is going to go up by the size of the drop in the real interest rate. And if the output gap goes up, what happens to inflation in the Phillips curve? It goes up by kappa times the change in the output gap. You guys see what's going on here? What do we start with? The demand shock initially caused the output gap to fall and inflation to fall, but the central bank lowered the nominal interest rate in response to that development enough to lower the real interest rate, which raises the output gap somewhat. And that gets fed through back into the Phillips curve, which raises inflation a little bit. So what we have here is the shock causes the output gap and inflation to fall, but because the Fed responds systematically to that and accommodates monetary policy, both the output gap and inflation rise a little bit. And so neither of those two variables fall by the full amount of the shock in the model. And the fundamental reason why is because baked into the analysis is the assumption that the central bank here is going to try to offset the negative demand shock by lowering the nominal interest rate. And it achieves that by actually accomplishing a reduction in the real interest rate. That only happens if beta pi is bigger than 1. If the Fed doesn't react strongly enough to inflation, that is, it violates this thing called the Taylor principle, then it leads to a great deal of macroeconomic volatility, which we'll show in the next class. Okay, does that make sense? So that's kind of the analysis that I'm going to want you all to do, is to show graphically what happens when there's a change in one of these exogenous features. But then I want you guys to be able to work through the logic of the transmission mechanism, right? How does it affect the IS curve? How does it affect the Phillips curve? How does the central bank respond to those developments? And how do those movements in the real interest rate get fed back into the model? So an argument sort of like this. Let me expand on this. I think the more of this we do, the better you guys will understand it. Can the central bank fully stabilize the economy here in response to the demand shock? Can, in principle, the Fed fully insulate the economy from a fall in the output gap and a fall in inflation? If so, how could it do that? What does the policymaker here have the ability to choose? The strength with which it responds to the inflation gap, right? All we've said here is that beta pi is bigger than 1. It could be 1.1, it could be 1.5, it could be 1,000, right? What happens here if beta pi gets really big? So the central bank aggressively tries to respond to any movement of inflation from target inflation. What happens to the shape of the ISMP schedule? We did this on the last graph. Michael? It flattens, right? Let's do an extreme kind of case. Michael, let's imagine that beta pi gets really big, okay? What happens to the ISMP curve? It becomes nearly horizontal, all right? That's this red line here, okay? Now, Michael, imagine that the same, so this is the original line, right? Imagine the same size demand shock occurs so that we get the same horizontal shift in the ISMP curve. What do you see happening here? In equilibrium, we move from here to here instead of from here to here, right? And so there is a much smaller reduction in the output gap and a much smaller reduction in inflation. If beta pi goes all the way to infinity, Michael, then this coefficient, the slope of the ISMP curve is 0, and it becomes perfectly horizontal. And when that's the case, you notice from the ISMP curve that inflation will always be equal to target inflation. So the central bank will be able to fully stabilize inflation in response to the demand shock. Now, let's think logically about why this is happening, okay? Suppose there's a demand shock that causes the output gap to fall, and through the Phillips curve, it causes inflation to fall. Now, Levi is my central banker here. Levi, you see that inflation is falling below target. What do? You lower the nominal interest rate, but you lower it a ton, right? Because beta pi is a really big number. In fact, you lower it so much that the real interest rate falls sufficiently enough to bring the output gap all the way back to 0. And if you can do that, then you can bring inflation all the way back to pi 1. So the point here is that in response to a demand shock, the central bank in the new Keynesian model can actually fully stabilize the economy in response to these demand shocks, as long as it aggressively tries to counteract the inflation gap, that is with a number for beta pi that is really big. The Taylor rule implies that beta pi is 1.5. Okay, let's do another example. What if I told you that the economy experiences an inflationary supply shock? Now, I want you guys, or perhaps somebody on Zoom, to talk me through this one, okay? So, again, let's start over at the initial point. We've got our downward sloping ISMP curve. Target inflation is equal to pi 1. There's no demand shocks. And we have our upward sloping new Keynesian Phillips curve with expected inflation also equal to pi 1 and no supply shock. And so here is our initial equilibrium point, a zero output gap and a level of inflation equal to pi 1. Now, what if I told you what happens in the new Keynesian model if there is, let's say, an adverse or inflationary supply shock? Let's say that there is some disruption in the oil markets. There is a war that breaks out in the Middle East somewhere. And so that puts upward pressure on prices, independent of marginal costs in the output gap. How does that affect the business cycle in the new Keynesian model? So let's go through the steps. Let's just, before we go through the math, let's just analyze it graphically. Does it affect the Phillips curve or the ISMP curve?
The Phillips curve.
It's going to affect the Phillips curve. And Lauren, what direction does it shift?
It'll go upward.
It's going to go up. The Phillips curve is going to shift up, and it's going to shift up by the size of the supply shock, right? If epsilon is positive and the output gap is 0 and there's no change in expected inflation, then inflation rises from pi 1 to pi 1 plus the supply shock. So the Phillips curve shifts up by exactly the size of the supply shock, or shifts back by the size of the supply shock. Okay, and what is going to happen in equilibrium then? We're going to move from an output gap of 0 and an inflation rate of pi 1 to what? A negative output gap and a somewhat higher level of inflation. So there's going to be stagflation, negative output gaps and higher inflation, okay? You will notice, however, that in equilibrium, inflation does not rise by the full amount of the shock, nor does the output gap fall by the full size of the shift in the Phillips curve. In other words, within the new Keynesian model, there's something going on that's causing the output gap and inflation to be partially stabilized in response to this adverse supply shock. What is it? Let's work through the analysis of the transmission mechanism. Okay, so again, fix your eyes on the equations of the model and think precisely about how the supply shock would be transmitted through the rest of the economy. Why doesn't inflation rise by the full amount of the supply shock? Who wants to give this one a try? Not me. I don't want to give it a try. I want one of you all to give it a try.
So if epsilon increases,
hold on, Lauren, I'm going to turn up the volume just a little bit. Okay, go ahead, start over.
So if epsilon increases, like you said, it's going to increase the left-hand side of the Phillips curve.
Okay, let's start there. Exactly. Epsilon goes up, then inflation is immediately going to rise higher. Perfect. Okay, then what?
And because inflation goes up, then we have to look at the coefficient beta pi. So we have to look at the monetary policy curve, I think.
So, okay, one step at a time. Higher inflation is going to create a response by the central bank. And if you look at the monetary policy rule, if inflation rises above target, the central bank here is going to want to raise the nominal interest rate. And just like Lauren says, the policymaker is going to raise the nominal rate by beta pi times however much inflation increases by, which was epsilon here. Very good. Okay, Lauren, next step.
So then the inflationary gap is going to increase because real inflation, and then the interest rates also increase.
Okay, yeah, so let's be careful about this. The nominal interest rate, I, goes up. That's the variable that the central bank has direct control over. But in order to determine how that policy maneuver affects the rest of the economy, you have to ask yourself what happens to the real interest rate. It's the real interest rate that in turn feeds back into the IS equation, right? The real interest rate, of course, is the nominal rate minus the rate of inflation. So if the nominal rate goes up by beta pi times epsilon, how much does the real interest rate change by?
It'll be the beta pi minus 1.
That's right. It's beta pi minus 1 times epsilon. That is the change in inflation, right? So remember, the real rate is the nominal rate minus inflation. So if inflation goes up, that causes the real interest rate to go down. But if the nominal rate goes up, that causes the real rate to go up. So does the real rate go up or down? Well, it depends on which of those effects is bigger. Lauren, which effect is going to be bigger? The nominal rate or the movement in inflation?
I think the nominal rate, right?
That's right. And it's because beta pi is bigger than 1. The Fed is changing the nominal interest rate more than 1-for-1 in response to a change in inflation. And so the real interest rate goes up. Perfect. Now, if the real interest rate goes up, what then happens to the output gap in the IS equation?
That'll go down.
That's going to go down by the same percent, right? So the output gap goes down. Now we're getting somewhere. And if the output gap goes down, what happens to inflation in the Phillips curve?
It also goes down.
It also goes down by kappa times the change in the output gap. And so what have we demonstrated here? The inflationary shock causes inflation to rise, but because the Fed responds to that by raising the nominal interest rate enough to raise the real interest rate, that causes the output gap to go down some and therefore causes inflation to go down in the Phillips curve. There is this stabilizing response of the central bank baked into the equations of the model, okay? And so inflation goes up as a result of the shock, but then comes back down a little bit because the Fed is trying to offset the supply shock, right? And as inflation comes down, the output gap is also not going to fall by the full amount of the shock as well. So we see here that the central bank has been able to at least partially stabilize the economy in response to this adverse supply shock. Does that make sense? Lauren, good job.
Thank you.
So that's kind of what I'm looking for on those type of problems. How does it affect the equilibrium graphically, part one, and explain the transmission mechanism to me? That's important, right? Because you see, even in this very small, simple model of the economy, how the different variables feed into each component of the economy. The output gap is what drives inflation over the cycle. Inflation is the key variable that the central bank responds to. But that interest rate feeds into the IS equation and therefore affects the output gap over the cycle. So all of these things are kind of happening simultaneously. And we use the equations of the model to try to interpret what's happening to the business cycle, okay? Let me ask one more follow-up question here. What if the Fed responded real aggressively to this supply shock? That is, its setting for beta pi was a large number. Again, what happens to the ISMP curve in that case? Do I have this in the slides? Yeah. So I've got this a little bit out of order, but The red horizontal line here shows us what? When beta pi goes to a large number and the Fed wants to aggressively respond to changes in the inflation gap, then what happens? The ISMP curve becomes perfectly horizontal. Now notice what happens here. In response to a supply shock, what happens to the rate of inflation in equilibrium? It's still pinned down at pi 1. But what happens to the output gap? The output gap ends up falling by the full amount of the shift, which in this case is negative epsilon divided by kappa. The math there is pretty straightforward, okay? If beta pi is infinite, then we know from the ISMP equation that inflation will always equal target inflation. So that means inflation is going to be equal to pi 1. Now, if we go up to the Phillips curve then, if there's no change in expected inflation, then actual inflation, which is the same as target inflation now, is equal to expected inflation. And we can solve the Phillips curve then for the output gap. It's just negative epsilon divided by kappa. And so the output gap is going to fall by the full amount of the shift in the Phillips curve in that case. However, inflation is completely stabilized. So what do you see differs between a demand shock versus a supply shock? This is a key point that I was hoping to get before we conclude today. In response to a negative demand shock, what was the central bank able to do? By aggressively responding to the shock, by setting beta pi to a big number, it flattens the ISMP curve and fully stabilizes inflation in the output gap. What happens in response to a supply shock, though? The central bank can aggressively respond to that, but it only fully stabilizes inflation. The cost is going to be a larger recession. This is the key distinction between so-called aggregate supply and aggregate demand shocks. Demand shocks do not pose a real problem for central bank stabilization policy in theory, because the central bank should be able to fully offset demand shocks. What the central bank cannot fully offset are supply shocks, right? They can either stabilize inflation at the cost of a large negative output gap, or, Michael, if beta pi was equal to 1 and the ISMP curve was vertical, then what would happen? The output gap would be pinned at 0, but you would have inflation being higher by the size of the shock. So in response to supply shocks, the Fed faces a trade-off between stabilizing the output gap and inflation, right? And that trade-off is embedded in the Phillips curve, okay? That's one kind of key distinction between those two examples that I wanted you to understand there. Now, unless I say otherwise, you can assume that the central bank just responds in a normal way to the inflation gap, so that the ISMP curve is just this regular downward slope. If I ask you what happens if they try to fully stabilize the economy, that's when you allow the ISMP curve to be perfectly horizontal. But that would be clear from the problem that I'm giving you. Okay, I'll tell you what, let's do this. I've got a third problem that practices the same analysis, but this time looks at the effects of a change in expected inflation. So we looked at the demand shocks versus supply shocks. We've got one of these solved problems in the slides that looks at the effects of a change in expected inflation. Let's do this as a recap review problem at the beginning of class on Wednesday. What's today? Today is Wednesday. Next, I've completely lost track of time. Today is Wednesday, right? Next Monday, and then we'll go on and talk about the Taylor principle and what happens when the Taylor principle is violated in this model. We'll get through all of that on class next Monday, And that will leave me next Wednesday then to cover a really interesting but somewhat more complicated topic, and that is zero interest rate policy. What happens in this model if in response to a negative demand shock, if the Fed or the central bank tries to lower the interest rate so much that it hits the zero lower bound on the interest rate? That is no longer just a theoretical curiosity. It's not, right? Because we've seen in the past 2 recessions, the Fed has bumped up against the zero lower bound. So I think it is important to show how we do that type of zero interest rate policy in the context of the new Keynesian model. And we'll do that next Wednesday, all right? Okay, guys, good job today. I'll see you next week. Have a good weekend.